Most people go through life trying to not get hit.
What's up, man?
All good.
You see that fight?
Oh, did I? Think I could have won. The trick is to roll with the punches and hope that you don't get floored by one. Our world was born out of violence and a storm that has raged since the beginning of time. A storm with the power to destroy planets. One mighty collision can change everything. It's done it before, and it could do it again. Most of us live in blissful ignorance of the chaos around us. But 8 astronauts with over 1,000 days in space between them can tell us how being up there helped them to truly understand what goes on down here.
Every day, the Earth plows through about 40 tons of material in space.
There's so much activity, so much action, and our planet is right in the middle of it.
Space isn't a vast and empty space, but a dynamic cosmic storm.
It's a storm that could kill us. But without it, we wouldn't be here at all.
This is a story about the weird connections, the near misses, the lucky breaks that created this amazing world. For 4.5 billion years, our planet has been battered and bruised and punched and pummeled. But we're still standing. It's actually the battle that's built us. And this is the tale of the tape.
Thanks, guys. Awesome. All right.
Nicole Stott is an engineer, pilot, and, oh yeah,
So cool, huh?
she lived for 3 months in space.
You can even stick your hand in it. Left hand.
Okay, coming out.
Nicole, your right waist tether to the forward UIAV ring.
Frankly, she's a badass.
Now imagine them all pressurized and you having to work against it really hard. Here I was, it was so unbelievable. I'd spent almost 20 years helping build spaceships, and now here I was myself on one. Just amazing.
Okay, I am clear, Nicole.
Remember watching me do a spacewalk?
Yeah.
Yeah. Was that fun?
Scary.
Yeah. Why was it scary?
That you're gonna fall off.
When you're in space, 250 miles above our planet, and looking at these things you thought you knew, you see them in a totally new way. For example, the first time I saw a shooting star from the space station was this very visual reminder that there's a lot of other things traveling through this same space in space.
What I did see, and the first time I saw it, it kind of startled me, was a shooting star coming in below us. That's a micrometeorite coming into the Earth and burning up in the atmosphere, and you see this sort of firework display thing going on.
I was doing Earth observation, and I'm taking a photo, and all of a sudden I see a hole just magically appear about that big in the solar panel. You know, that was probably hit by a grain of sand, something that size, coming at 17,500 miles an hour in a different orbit.
You get hit by rocks all the time. You can hear them ricocheting off the hull. You can see the scars of them in the windows of the spaceship.
It's a little mind-boggling when you think about how much is really out there.
Mostly the stuff up there is pretty small, burns up in the atmosphere, nothing to get worked up about. But there's some pretty big rocks up there too. Ask the dinosaurs.
We believe the asteroid that caused the extinction of the dinosaurs started way out in the solar system. You know, traveling that distance, it's incredible that it found this target of Earth. Bad for the dinosaurs, but ultimately good for us.
We all think we know this story, but there's something special about the place where it happened, in the jungles of Mexico.
Here in Mexico, I have the chance to dive in what is the most magical place to free dive in the entire world. This incredible place was created with very strong violence when the asteroid hits. And the result of this is this calm place, this paradox. This place, which is now very quiet, was at some point where something dramatic happened. Life almost disappeared. But at the same time, this is where our story started, and this is why we are here now.
When this area was scanned, we saw that hundreds of these flooded Mexican caverns connected together into a vast semicircle. The edges of a huge crater, 110 miles across and 12 miles deep. An asteroid that big hitting the planet anywhere is going to be devastating. But scientists think it was especially devastating because of where it hit. a bullseye strike on a large sulfur reserve. The sulfur rock vaporized, sending billions of tons of polluting gas into the atmosphere, blocking out the sun. The Earth froze, and the dinosaurs died.
So, this big old asteroid's been journeying for billions of years through space before it gets to us. And the Earth spins, right? So if the rock had arrived just a few seconds later, it would have crashed out in the deep ocean. No bullseye, no firestorm, no dino extinction. Earth's history is full of moments like this. It's a tale of destructive good fortune that connects the death of a planet, 10 million African bats, a clock in the sky, and tiny rocks from the birth of our solar system. Some about the size of my fist.
There's a lot of rocks hitting us from space. If they make it through our atmosphere and hit the surface of our planet, people go in search of these in very remote places to try to find them. They're extremely valuable because they contain really the story of where our Earth came from.
رمضان عليك
مرحبا 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 عسيت اللي غنى نايلو قتليا نحو غادي ضرنا كيقيم السيد ذا عرفتي يا راه غنوسق ساغانهم غير خاطر هادي اللي حصير بيض تسلحوا عمو تسلحوا عمو
In Morocco, we have a couple of buzzes every year of something that's way cool, a super awesome meteorite. If a meteorite is found in a desert and word gets out, especially if it's of extreme value, then there is like a gold rush. We're talking about the building blocks of our planet. Some of the most valuable meteorites are carbonaceous chondrite meteorites. They're the oldest form of solid material in the solar system. All the universities want it. All the museums want it. The Bedouins are getting amazingly good at recognizing these things.
فهور هذه؟
ايوا الوقت
شنو جبتي؟
ايوا جبتي ميتيوريت هنا تشوفها
ميتيوريت بعدا 100%؟
100%.
فوالا فين تلقات هذه؟
هي تلقات الطوس.
اوكي لا كربونيت هذيك. وشحال الحراره شحال الثمن؟
هو شوف انت
70 درهم. يلا توكل عليك. الله يرحمه الله جبتي سير دابا صيفط لك.
To the untrained eye, these might just look like a normal rock. But the really old ones contain all the raw materials to build a planet like Earth. 4.6 billion years ago, where Earth is today, there was just a giant cloud of gas and dust, all swirling around the newborn sun. This was where the cosmic storm started. First off with tiny particles, attracted by an electrostatic force. It's a slow process, but eventually clumps grew into solid matter. Still only as big as a grain of sand, but now with just enough gravity of their own to pull other grains in. These grains fused into rocks, and as they smashed and clumped, the collisions grew in intensity. Under immense heat and pressure, the rocks began to build our planet. There seems to be nothing subtle about the way Earth was built. It would almost be like building a space station with a sledgehammer.
All those bits smashing together, they were everything we needed to build a living planet. The calcium in our bones, the gold in our wedding rings, even the iron in our ships was all here from the beginning. Except one thing was in short supply: water. But it was on its way and coming in fast.
A lot of astronauts will tell you that from 6 years old, watching the moon landing, that they knew from that moment on that astronaut was a job that they wanted to do. For me, it wasn't that way. My background is aeronautical engineering. I wanted to do something with flying that allowed me to learn about how things fly. And then ultimately, if you want to know how things fly, I can't imagine not wanting to know how rocket ships fly. And then one day I got this phone call to say that I was assigned to fly a long-duration flight on the International Space Station.
Nicole didn't set out to fly on the ISS. Her job was to build the thing. But once she got up there, she still had an eye for design.
So as an engineer, you can imagine, I couldn't help but look at the Earth and wonder, how does that work? What's blindingly obvious when you look at Earth is water is the key. But early Earth didn't look like this blue planet that I saw. It was a dry and barren rock. For life to thrive like it has done, the Earth needed a delivery of water. We believe soon after the Earth was formed, our water came from space in a hail of violence. It must have been brutal. We think it lasted for about 100 million years. Icy comets and asteroids collided with the planet again. To supply us with that top-off of water. But unlike Mars and Venus, who were surely bombarded by this same storm, we kept our water. As luck would have it, the seed that would one day grow into Earth as we know it found its place at the perfect distance from the sun, what we now call the Goldilocks zone. Not too hot, not too cold.
The solar system is vast. Earth could have easily wound up somewhere where every drop of water either froze up or boiled away. But here, it's solid, gas, and liquid all the time. It only takes a tiny change like a sunrise for things to get a little bit slippery.
For me, the most exciting thing for ice climbing is that it's just water. Every year it changes its structure, it never grows the same. It always looks different, so each ascent is unique. Of course, if it's more than 0 degrees, the ice starts to melt, and at some point it can just collapse.
Solid, liquid, gas. Earth's water, it's a shapeshifter, constantly changing forms. And as it moves from snow to sea, from stream to steam, it helps make the weather that keeps this planet a paradise for life.
From space, you can see clouds at the tops of the Amazon basin, but you can also see them evaporating on the oceans. And so these systems are all interconnected.
That natural, seemingly inevitable process of turning the oceans into rain, it's the very essence of life itself on Earth.
Without it, there would be no rivers, no groundwater, no plants, no animals. The continents would be dead.
It actually surprised me how dynamic the planet is. Clouds whirling, lightning storms propagating over the surface, the ocean currents visible, and you realize this thing is not a dead rock down there. This thing is alive.
So we can thank our lucky stars, I suppose, that the seed that started Earth was in the right place for water to exist in its 3 states.
Our planet was born out of cosmic dust, then watered by a storm from above. But all those blows were nothing compared to one that literally ripped the Earth apart. You see, Earth had a twin that threatened our existence. The Earth is the result of many, many collisions. But the most violent collision of all was unknown to humankind. Unknown, that is, until we went to the moon.
I have really vivid memories of our first moon landing. Sitting in front of the black and white TV. For some reason, I remember having a grilled cheese sandwich. Who knows?
Hello, Apollo 11, Houston.
We thought, how could there possibly be anything in common between the Earth and all its beautiful earthly colors and the gray of the moon?
Oh, that looks beautiful from here.
This cratered surface.
Stand by. It's different, but it's very pretty out here.
What we found surprised us. Moon rock and Earth rock had striking similarities.
We'd like you to press on. Yeah, right here.
Suggesting that both the Earth and the moon had somehow originated from the same place.
That's one small step for man.
Well, there's only a handful of ways that could have happened, and none of them are pretty.
The prominent theory is that there was something else in the Goldilocks zone. Another planet called Theia, and it was on an intersecting orbit with Earth. In space, when two things are in an intersecting orbit, with enough time, it's inevitable that those two things will collide. Both planets became molten on impact. We have debris thrown out into space. When this cloud of debris eventually cools, it condenses into a new cosmic partnership. Planet Earth and a uniquely large moon.
Our moon was ripped right out of us. Because of that, it's big and close and has a lot of pull. Pulls the sea in, pulls the sea out, tides. Simple, right? But things get harder when that same sea is covered by ice. Which is something that granddads know and modern kids could stand to learn.
Gingawa ilchigeli ingakanaktosyong michano. Kelly, ulit pala si Gibok. Ay, muna pe. Ano siyang ito ka tayo umilit. Ilagay mo yun, no? Nikiksatalim makisiko atani. Kisiani kaya magahaktuti namungalang mangakpi. Takhik ilito tilogo tinilo ataso.
Lucasay knows when the moon is full, the tide is strongest. And they'll have a few more minutes under the ice. The best chance to grab their catch.
No sakit. Không có dư đất rồi. Sabi, ano kaya halagabit?
We shouldn't underestimate how influential the moon is in all of our lives. Those regular tides also help give us another kind of rhythm. One you might assume had been with us all along. The collision that ended up forming the moon sent the Earth just spinning. A day back then was just 5 hours long. It was the drag of the tides that eventually slowed the Earth down to where a day became 24 hours, like we know now. The 24-hour day. Waking up, having breakfast, working 8 hours, making dinner, day in, day out. These cycles, they're embedded in our DNA.
The violent whack that gave us our moon, our tides, and our 24-hour day, it gave us one more thing too. Summer in Philadelphia.
When I think of the space station, I think of this like beautiful masterpiece in space, just hanging there. The ultimate engineering challenge was, how do you make your spaceship as much like Earth as possible? Crossing the hatch from the space shuttle into the space station the first time, I remember thinking, wow, it's not the neatest place I've ever seen. There's wires and cables and computers and equipment all strung along these walls. The way we live there is we've essentially mimicked what we have naturally occurring on our planet. We have to generate the oxygen to breathe. We have to generate the electricity to power all of our systems. We have to figure out a way to clean the air so we can continue to breathe. Because we're human beings and can only live comfortably really within a certain temperature range, the whole space station, all of the systems are working really hard to maintain that environment for us. And then you look down at Earth and you realize that's exactly what nature is doing, just on a mind-blowing scale. got that cosmic collision that made our moon to thank for it.
Oh, wow.
That collision between Earth and Theia was so violent that it actually knocked Earth off its axis.
Oh.
There you go. So let's just pretend this is our sun and this is our Earth. And our Earth is tilted. Due to that collision, tilted 23.5 degrees. For 6 months of the year, the northern hemisphere is favoring the sun. And for 6 months of the year, the southern hemisphere is favoring the sun. The shift in the sun's energy from north to south throughout the year is constantly trying to move the hot areas to the cold areas and the cold areas to the hot areas. This tilt of the Earth results in our seasons.
The seasons constantly change and shape and contour the land underneath. The world is constantly adjusting itself.
From the vantage point of space, you can see the ever-changing planet through the seasons, from snow-capped mountains to desert plains.
I really never thought of this until just very recently. You know, I'm seeing all the seasons at once. So I'm seeing the winter in the northern hemisphere and it's summer in the southern hemisphere.
If we had no tilt, nearly half the planet could be frozen all year round. Nicole would be fine in Florida, nearer the equator, but growing up in Philly, there'd be a glacier in my backyard.
Because of our tilt, there really are few places on this planet where life can't thrive. Life on our planet has synchronized with our seasons. Raising its young in the spring and readying them for winter.
Four and a half billion years ago, we started with a smash that created a tilt that made our seasons that gave us the rhythms of existence. But more than that, it gave us the diversity of life we see around us.
About 5 minutes past 6, the first bats will start coming out. It seems somebody has given a sign. Quickly they become hundreds. Before you know it, there are millions up in the sky. It's the largest mammal migration on Earth. They fly out in every direction, covering an area of 10,000 square miles.
Hard to imagine, but for most of the year, not a single one of these bats lives here. All 10 million arrive from across Africa, chasing the rains, to gorge on ripening fruits.
Every single night, they will consume roughly half their body weight in fruits. So considering that we got about 10 million, that is roughly 1,000 tons of fruit every single night. They will eat the fruit and with that also digest the seeds. After that they will move some distance, which might be 50 or 100 kilometers. By that time the seeds will have passed through the digestive system and will end up somewhere there on the forest floor. We are looking at literally billions of seeds flying all over the continent.
These bats are essentially a flying forest delivery system. The tilt of the earth means cold moves to hot and hot to cold. It means winter gives way to spring just as summer yields to fall. It means bats fly across a continent, seeding forests as they go. The world is connected in 1,000 ways, and all because of one massive whack. So, is the danger all in the past, or is this the calm before another storm? This planet is only here because we've weathered just enough body blows to build our world. So far, it's been a perfect storm that's made our perfect home, one that feels stable, safe, reliable. It isn't.
Imagine yourself on a boat. Out in the middle of the ocean. In the middle of a storm. A big storm. It's very real to you. It might even be a little bit scary. But if you had the opportunity to just zoom in on one of these tiny little droplets and see that inside that little droplet are these tiny little microorganisms that are just oblivious to this storm going on around them. And if we look at our Earth, if we look at where we live, this planet that's out in space, we in some ways go about our daily lives oblivious to all the action that's going on around us in space, in the solar system, in the universe. This cosmic storm that actually has a violent nature to it is the reason why we're here, the reason why we're able to live so comfortably on this planet. Before flying in space, I tried really hard to learn from the people who had flown before me, to get some idea of what the experience meant to them. These astronauts had seen the whole Earth from space. While they described it as a really incredibly beautiful place, there were also some that said they felt a sense of insignificance. From the very first time I looked out the window, I felt like this is significant. The significance of it to me is how something so overwhelmingly beautiful could have come from chaos, violence, and collisions. It's just amazing to think about this fine line, this balance between being here, surviving, thriving, and not.
The storm has not been our enemy. We aren't here in spite of it. We're here because of it. And when the storm blows over, it's anything but blue skies and rainbows. Next time. Here comes the sun. It is the fuel of life. But it is not our friend. The sun is a planet killer.